Good morning, friends. How are you? Okay, today we are studying 8051 microcontroller block diagram. In this 8051 microcontroller, we have the different components. First of all, CPU, then system bus, memory, RAM and ROM, then timers or counters, then bus control, I/O ports and serial ports. Now in this CPU is the main part of our computer. That is called as heart of the computer. That means it is heart of the 8051 microcontroller. The CPU consists of arithmetic and logic unit, control unit and registers. CPU, we can call it as the CPU registers. Now, arithmetic logic unit perform arithmetical and logical functions such as addition, subtraction, ANDing, ORing, XORing, like that. With that, the CPU registers are general registers which used for during ALU operations. The system bus consists of three bus systems, that is address bus, data bus and control bus. The data bus normally identifies that word length, then address bus defines size of the memory, and individual control signals are controlling that the peripheral devices. Now all these components are internally connected on a single chip. So that's why this architecture is called as a SoC, system on chip. It has the memory, that is RAM and ROM. So 8051 microcontroller family has 128 byte of internal RAM. So this is the actually a data memory. So that program can be run or execute in this 128 byte of RAM. This 128 byte of RAM is again divided into the number of special function registers, then bit addressable RAM as well as register banks. It has 4 banks, that is bank 0, bank 1, bank 2 and bank 3. Each bank consists of total 8 registers, that is from R0 to R7. Now it has a 4 kilobyte of internal ROM. So externally it can be accessible 60 kilobyte of ROM. So this is the program memory, can be accessed a 4 kilobyte of ROM. Now CPU can generate the address to this ROM. So this address can be stored in the program counter. Now this ROM is used to store a program. Now it has I/O ports. So it has actually the 4 I/O ports, that is input output port, that is port P0, P1, P2 and P3. Each port is a bidirectional. That means it can flow the data in both the direction. The port P0, P1, P2 and P3. So port P0 and P2 is assembled to the one side, and port P1 and P3 is assembled to the another side. That means even port is to one side and odd port to the other side. Now this port is used to transfer the data. Some of the port, that is port P3, is having the multiple functions. That are some control signals are used to the P3. The port P0 has the do not have the internal pull-up register, but other ports has the internal pull-up register. While we configuring that the port P0, that it requires internal pull-up registers. Now also it has one serial port. This serial port is used to transfer the data and receive the data serially. The serial operation is performed in the two ways. One is called as asynchronous serial transmission or reception, and synchronous serial transmission and reception. Now here RSD pin is used to receive the data, and TSD pin is transmit the data serially. So it also has one serial buffer port, so which store that the data externally. Now it also has 2 timers, that is timer 0 and timer 1. The timer 0 and timer 1 both are a 16-bit timer. So it store actually it is store 65,536 byte of data. That is in general 64 kilobyte of data, and the counters are used to count the clock signals. Bus control. Bus control is nothing but it is having a different control signal which controlling all the peripheral devices internally as well as externally. So this bus control is nothing but an individual control signal to give the instructions or some of the interrupt signal to the peripheral devices. Now this main part is the interrupt control. So first of all, let me know what is interrupt. Interrupt is nothing but we giving some particular signal to perform a specific task. So that signal are called as an interrupt signal. So this 8051 has a total 5 interrupt signals. The 2 interrupt signals is for the timer signal. Then 1 is a serial control signal, and 2 are internal interrupt signal, that is INT0 and INT1. So that are the 5 interrupt signals are very important interrupt signal, that is the hardware interrupt control. Now every processor requires a clock cycles or clock signals. That clock signal is generated by the oscillator. Normally this oscillator is a regenerative circuit which generate that clock signals. So for the better oscillations or better generation of the clock signals, the crystal oscillator is normally used. So it is the crystal oscillator has the better stability. So that's why this crystal oscillator is normally used. So this crystal, now in 8051 microcontroller, that oscillator are used as near about 10 megahertz to 35 megahertz oscillators are used to generate